Hello everyone, and here is a probability question. It says a large college produces 3 magazines. One of the magazines is about green issues, one is about equality, and one is about sports. A student at the college is selected at random, and the events G, E, and S are defined as follows. G is the event that the student reads a magazine about green issues. E is the event that the student reads a magazine about equality, and S is the event that the student reads a magazine about sports. The Venn diagram, where P, Q, R, and T are probabilities, gives the probability of each subset. Find the proportion of students in the college who read exactly one of these magazines. Okay, so exactly one, we can see that it's going to be this area here. This is only green issues. This one is only equality, and this one is only sports. So it's going to be only green issues, which is 0.08. or only equality, which is 0.09, or only sports. So we add those together, and that is 0.53. So that's our answer to part A. Now it says no students read all 3 magazines, okay? And the probability of G is equal to 0.25. So if nobody reads all 3, then that means that P in the middle there is equal to 0. Okay, which is super useful to us. And now that we know that P is equal to 0 in the green part of the Venn diagram, we're now going to be able to work out the other bits, because in the green part, we've got 0.08, we've got 0.05, we've got P, which we now know is 0, and we've got Q. So we know that 0.08 add 0.05 add Q is equal to 0.25. So from that, we can rearrange that and just find out what Q is. And that gives us that Q is equal to 0.12. So that is the first part done for part B. We've worked out, oh, in fact, actually, no. We've worked out, that is B part 1 there. We've worked out that P is equal to 0, and B part 2, we found out that Q is equal to 0.12. Okay, so far so good. Now, this is a super important idea coming up now, conditional probability with a Venn diagram. It says, given that the probability of S given E is equal to 5/12, okay, find the probabilities of R and T. Now, in order to do this, when we have a conditional probability, the probability of S given E, what we need to understand is that that reduces the sample space, okay? So when we have given E, it basically is like the entire sample space is reduced to only include the E portion of the Venn diagram. So if I just represent that now, because we have given E, everything else has gone. We have the P, which is 0. We have the 0.05. We have the 0.09, and we have our R there. Okay, so the probability that it is in S given that it is in E. Now let's look and see which bit is the sports bit. Well, this is our sports part. That is our green issues part. So the probability that it's in S given that it's in E is equal to the probability of S intersection E over the probability of E. And S intersection E is just this little bit here. This is the bit that is in both S and E. So that is equal to R over just the denominator is the reduced sample space, which is just the E. So 0.09, and then we have plus R. Okay, that's perfect. Now we're told that this is equal to 5/12, and we can use this now to calculate what R is, because we now have R over our 0.05. So we've got R over 0.14 plus R is equal to 5/12. And we can now cross multiply and find out what our R is. So 12R is equal to 5 times by 0.14 plus R. So we can calculate that is 12R is going to equal 5R plus 5 times 0.14. 5 times 0.14 being 0.7. So when we work that out and we rearrange that whole thing, we find out that R is equal to 0.1. Okay, that's perfect. So we've now found out what R is. So the last thing we need to find out now, so that's C part 1. The last thing now is C part 2, which is to find out the value of T. Now, in this Venn diagram, all of the probabilities add up to make 1. So we can just use the fact that everything, because the only thing we don't know now is T. Okay, so we're just going to say that 0.08 plus 0.05 plus our 0.12 plus the 0 plus the 0.09 plus the 0.10 that we've just found plus 0.36 plus T has all got to equal 1. So everything's got to add up to make 1. And when we basically take all of that away from 1, we find out that T is equal to 0.20. So we found all of our probabilities, but I think that reduced sample space idea for conditional probability is very important. Okay, the last part of the question now, part D, it says determine whether or not the events S intersection not E and G are independent. Show your working clearly. Now, if they were independent, we're going to use the fact that for independent events, the probability of A intersection B is equal to the probability of A times the probability of B. So in this case here, the probability of S intersection E, an intersection of that with G, if they're independent, should equal the probability of S intersection not E multiplied by the probability of G. If this is true, then the events are independent, okay? So first of all, let's have a look and see what is our probability of S intersection not E. Well, S intersection not E, let's have a look at that. So we've got, it needs to be in S and it should not be in E. So the probability of S in intersection not E is going to equal 0.36 add RQ. So that is 0.36 add Q and 0.36. And what did we find Q to be? We found Q to be 0.12 earlier on in the question. Okay, so that is equal to 0.48. So there's our 0.48. That's our probability of S intersection not E. We know that the probability of G, we're told, is equal to 0.12. So if they are independent, let's see what our probability of S intersection not E multiplied by our probability of G gives us. So that is 0.48 times by 0.12. When we work out what that is, 0.48 times by 0.48 times by 0.12 is 0.0. Let's have a look at that. Let's just have a quick check. Probability of S intersection not 8. Oh, I'm sorry, I've written the wrong thing there. The probability of G. I thought that was a bit strange. The probability of G is 0.25, sorry. So 0.25, that's better. There we go. So let's see what that gives us now. 0.48 times by 0.25. That gives us 0.12. There we go. Okay, now let's have a look and see. So 0.12 is our intersection of S intersection not E and G. And if we look at the Venn diagram, let's see. So we've got our S intersection of not E is just Q and 0.36, okay? And the intersection of that with G is just Q. So basically, this bit here is just Q, okay? And we know that Q is equal to 0.12. So what we found is we found that the S intersection not E intersected with G is the same as the two probabilities tried to get multiplied together. They both equal 0.12. So therefore we can conclude that the events are independent. I hope that you found that helpful, and I will see you in the next video.